to all our viewers. You are welcome to today's episode. In today's episode, we are going to consider simple proof of duality using scientific principles. By scientific principles, we are going to use, in particular, elementary theorems or results or principles of mathematics. As we know, mathematics is an exact science and is a good representative of science in general. There is no doubt that mathematics is very important in establishing proofs, both in the physical world and in the non-physical world. At this juncture, I need to remind us, we need to be refreshed about the saying of one of the greatest mathematical philosophers who have traversed this earth before. And that is Bertrand Russell, a mathematical philosopher and the 1950 Nobel Literature Laureate. He said, and I quote, "Mathematics possesses not only truth, but supreme beauty, a beauty cold and austere, like that of sculpture. With this, we can see that mathematics can be considered both science and art. And in fact, in some universities, for instance, in the United States, you can earn your master's degree or bachelor's degree in mathematics, in arts, or in science. But that is by the wayside. We just want to emphasize the fact that mathematics is really very useful. It's a unifying factor in the whole of science. Maybe later in subsequent episodes, we are going to look in depth into the importance of mathematics, and we can see that mathematics is much more important than we actually are thinking about, than we actually are considering. So please sit back and enjoy today's episode, which is on duality in nature using scientific mathematical principles. Thank you. A simple duality proof in science. That is to say, we want to present a simple, procedure for establishing duality in nature. And we are using scientific principles, in particular mathematical principles, simple mathematics which majority of us must have been familiar with. So we can see this table: number, dual, simple proof. So we are just considering a variable x. Of course, the essence of using a variable is to make us realize that the x can be just any value, any number, so that the discussion is not limited to any particular number. So if we talk about the value x, the variable x, the dual can be considered to be minus x when you are talking about additive identity in terms of addition. And the simple proof of that is that if I add x to minus x, x plus minus x, I'm going to have x minus x, I'm going to have 0. So we have used a simple example. For instance, we have said, supposing x is 2, so we know that 2 plus minus 2 is going to give 0. Irrespective of the number you put here, irrespective of the real number you put here, you are going to have 0. If you put 20, if you put minus 50, if you put minus 50, if x is minus 50, by the time it's coming here, the minus 50 is going to be plus here. So it's still going to cancel out. It's going to be 50, it's going to be minus 50 plus 50, which will be 0. So whether you pick a negative value of x or a positive value of x, you are going to have 0. With respect to the additive property of numbers. Now let's move to the second simple proof. This one concerns the multiplicative property, identity of numbers. You can see if x, we have x, we are saying that the dual of x with respect to to multiplication can be considered to be 1 over x. And the simple proof of that is that when you multiply x by 1 over x, you are going to have 1, irrespective of the value of x you are considering. If I pick x is 2, just as we did with the additive property, you are going to have 2 times 1 over 2. 2 cut 2, so we are going to have 1. So this holds with respect to every real number pertaining to the multiplicative property of numbers. And this rule holds with respect to additive property. When you add x and minus x, you have 0. Multiply x and 1 over x, you are going to have 1. The reason is that 0 is the identity with respect to addition in mathematics, and 1 is the identity with respect to multiplication in mathematics. And that is why when you multiply any number by 1, you are going to get that number. Okay? And when you add 0 to any number, you are also going to get that number. So that explains the additive property and the multiplicative property in establishing duality using mathematics, which is a very good representative of science, because mathematics talks about truth, it's an exact science. Then we move to the concept of optimization, okay, which also is an applied form of duality. When you talk about optimization, the idea is to find the optimal value, let's put it that way, the value that you are going to get, such that when you combine all the various available resources, it's going to be the best value you can get. Take note, it is not necessarily the best value, it's not necessarily the worst value, but the optimum value. So, with respect to applications, we can talk about minimization, which is a dual of maximization. And when do you normally have minimization? You have minimization in situations in which you want the value of the quantity you are trying to explore, you are trying to measure, to be very low. For instance, if I'm transacting business to a businessman wants his loss to be very minimal. So you minimize loss. But in terms of his profit, he wants the profit to be the maximum. So you talk about the maximization of profit. So it's an applied form, an application of duality in science. Of course, we know that this is not purely a mathematics channel, but as we said, it involves science, theology, and philosophy. So we want to apply science to explain theology, to explain philosophy. And occasionally, we need to bring in some maths, but we try as much as possible to bring in mathematics that is not too advanced, so to say. So it means that in this channel, we can consider pure science, pure theology, and pure philosophy, or philosophy and theology in an episode, science and philosophy, science and theology, or we can mix all the three together in any particular episode. So please, that's what you should expect in this channel. So we move to the optimum points. So let's look at this diagram. We have the y-axis here, the x-axis here. It's a typical diagram that we are familiar with. This Cartesian coordinate system, named after that famous French mathematician and philosopher René Descartes. In due course, we're going to look at some of the philosophical statements of René Descartes. For instance, cogito ergo sum. I think, therefore I exist. That is one of his works in the realm of pure philosophy. But in the realm of mathematics, it's credited with the coordinate system. That's why it's called Cartesian coordinate system. So we have the y-axis, we have the x-axis. Let's look at this diagram. This is a straight line diagram. It's a linear diagram. we can see that for every particular value of y, for every particular value of x, we have different values of x. We could have called this 1, 2, 3, 4. But for any particular value of x, the y is the same. For this, x, y is the same. For this x, y is the same. For this x, y is the same. For this x, y is the same. So we can see that y is constant. And we know from elementary calculus that the gradient, which is actually the y dx, like we said, we don't want to go into more details, but we just give a sketch because we have a diverse audience, those who have some flair for mathematics or those who intend to refresh what they have done earlier on at the ordinary level. So it's the y dx, the change in y, all over the change in x. So we can see that between this point and this point, y does not change. So when we say that the y dx is increment in y all over increment in x. So the increment from here to here in y is 0. So we can always see that the y dx will be 0 because for the numerator, we are going to have 0 all over whatever value of x that you have. So, but if this diagram had been drawn here, it had been on this line, we would have been talking of something different because here, y increases will increase, but x will be 0. So when you say x is 0, so that means the denominator is going to be 0. And any number divided by 0 is undefined. So that will not be valid. So this is the simple sketch that is valid. So now let's look at the specifics with respect to minimum point and maximum point. With respect to minimization and maximization, remember we have said for optimum points, we just talked about the gradient. Increment in y all over the increment in x. That is for the optimum points. For the maximum, for the minimum or maximum point, we are going to talk of the second derivative. This is the first derivative, y prime dy dx. For the second derivative, we have y prime prime, which is going to be, we differentiate this again. So y prime prime is going to be d2y all over dx squared. Because here we are having actually dyy all over d1x. So this one will be d2y all over dx squared. So, and the particular thing we should take note of the sketch for a minimum, you can see that the way it is, it goes like this, and this is the point we can regard as a minimum point. And as a rule, a mathematical principle, for the minimum point, your d squared y over dx squared, which is y prime prime or y prime prime x, must be 0, is greater than 0. That is the basic principle with respect to minimum point. You can see that here we just have one minimum point. It's possible that you have many minimum points. You can see this diagram here. If you have a straight line here, so this is a minimum point, this is a minimum point, this is a minimum point, this is a minimum point. So it's still possible to have many minimum points. But the basic fact still remains that your d squared y over dx squared will be greater than 0. This is the x-axis, this is the y-axis. Many minimum points, single minimum points. That's how we have, and then this we have the optimum points, the y dx. We believe you have enjoyed today's episode. Please stay tuned and be expectant with respect to the next episode. In the next episode, we are going to continue where we stopped today. Today we stopped with respect to minimization. In the next episode, we are going to continue with maximization and look at the simple mathematical facts surrounding maximization. Thank you very much for staying tuned with this channel. Please, if you have questions, comments, please let us have them, and then we will, as much as possible, respond to such. We believe that such will also help us to really enhance this channel, the status of this channel. Once again, we appreciate you for joining us. Please stay tuned for the next episode that will be coming in the next few days.